Okay, so I'm multiplying a multivariate polynomial by a monomial. And so multiplication is actually a little bit easier than addition in this case, in my opinion. We have 6xy squared times 4y to the fifth minus 3x cubed plus 9. And so many teachers teach this by doing this thing. What I prefer to do is a different method called the area model, where I know I have one thing being multiplied by three things. This just helps me be a little bit more organized. And so this is how I'm going to approach it. I'm going to have negative 6xy squared out here, 4y to the fifth, the negative 3x cubed, and the positive 9. So the sign stays with the number, just like that middle term there is negative 3. And so we multiply the negative 6 and the 4, we get negative 24. X is the only x. Y squared times y to the fifth, we add the exponents as y to the seventh. Negative 6 times negative 3 is positive 18. The x times the x cubed is going to make x to the fourth. Again, we add the exponents, and then the y squared just stays there. Negative 6 times negative 9 is negative 54, and then the x y squared just stays the same. So now the answer to this is everything that's inside the boxes, and so negative 24 xy to the seventh plus 18x to the fourth y squared minus 54 xy squared. So 24xy to the seventh is 18x to the fourth y squared minus 54 xy squared. Okay. We get the next one. We have 5bc to the fourth times 2b squared minus 4b to the fifth c cubed plus 7c cubed. And so again, we are going to have one thing times three things, and so write our box out here. I'm going to make it a little bit bigger actually. Again, this is my preferred method of doing this. If you prefer to do the arrows, you can do that. 5bc to the fourth, 2b squared, the negative stays with the 4b to the fifth, c cubed, 7c to the third. So multiplying the numbers, I get 10. B plus b squared is b to the power of 3, c to the fourth. 5 times negative 4 is negative 20. B times b to the fifth is b to the sixth. C to the fourth times c to the third. We add the exponents, is c to the seventh. 5 times 7 is 35. B, c to the fourth, and c to the third again makes c to the seventh. The answer is everything that's inside the boxes, so 10b to the third, c to the fourth, minus 20b to the sixth, c to the seventh, plus 35b, c to the seventh. That looks like a 2. I'm just going to hit solve, make sure it matches. And it looks good. So we are going to try another. Just saving myself typing things in here. We'll do one more. We have negative 9 bc to the fourth times 6b to the sixth minus 4b squared c to the fifth plus 3c to the fifth. And again, I prefer the box method. Negative 9bc to the fourth, 6b to the sixth, negative 4b squared c to the fifth, 3c to the fifth. And again, you'll see I keep the sign with the number, so that negative 4 remains negative at that middle part in the box there. And I see it's going to be a pretty large portion of this, so I'm going to move that line over a little bit. Negative 9 times 6 is negative 54. B times b to the 6th is b to the 7th, and then c to the 4th. Negative 9 times negative 4 is 36. B times b to the power of 2 is b to the power of 3. We add the exponents. C to the 4th and c to the 5th makes c to the 9th. Again, we add the exponents when we multiply. Negative 9 times 3 is negative 27. B is still there, and c to the 4th plus c to the 5th makes c to the 4th times c to the 5th makes c to the 9th. So again, our answer should be everything that's in the boxes: negative 54, b to the 7, c to the 4. Looks like that matches, plus 36, b to the power of 3, c to the power of 9, minus 27, b, c to the power of 9. All right, and that's it for this video.